Hello, I'm the Math King, and in this video I want to present to you how you can find the derivative of a product of functions. So as you're watching this video, if you find that it's of any use to you, I would humbly ask that you like my video, and also if you could subscribe to my channel, that would be a wonderful thing. Anyway, what I'm about to talk about here, it has a name in calculus. It's known as the product rule. It's a somewhat more sophisticated shortcut. Uh, if you've seen my channel before, I have a video on what I call basic shortcuts. Um, but this is a somewhat more sophisticated shortcut than the ones that I label as basic. And again, it's a shortcut that enables us to find the derivative of a product of two functions. Before I get there, I want to remind us of what the definition of the derivative of single function is. So if we have a function f of x, then the derivative of f of x, which is sometimes also known as f prime of x, is given by this equation. And what we're going to do is we're going to apply that definition where the function that we have is really a product of two functions, f of x times g of x. When we apply that definition, here's what we get. And so to find the derivative of a product of two functions, f of x times g of x, it's basically the limit on that right-hand side. And just so we're clear, what I have here, the notation on the left-hand side of this equation, is basically I'm saying the derivative of f of x times g of x I've written in what's known as Leibniz notation. So this derivative, the derivative of the product of these two functions, is given by this limit that we see on the right. Okay, so that limit looks like but if we have any hope of evaluating it, once we do, we will know how to find a derivative of a product of two functions. To evaluate this limit, I'm going to do a little bit of a hack. And there we go. So there's the hack. It's in red. What I've done is I've subtracted a weird product. I've subtracted f of x plus delta x times g of x, and then I've added that same product back so that my new and much more complicated fraction is algebraically equivalent to the original fraction whose limit I'm trying to find. Why did I make my world more complicated? As it happens, it's a little bit easier to evaluate the limit now that we have this bigger fraction. What I'm going to do in these first two products, you can see that f of x plus delta x is a factor, so I'm going to factor it out. And in these last two products, you might see that g of x is a common factor. So I'm going to factor that out. So I'm going to factor f of x plus delta x out of the yellow, and I'm going to factor g of x out of the green. And when I do all of that, there you go. That's what I have. So I'm evaluating the limit of that fraction, which looks, I guess, about every bit as complicated as the original fraction here looks. But we're gonna break it up, and it's gonna come out to something nice, I promise. One thing that we see in this fraction is that in the numerator we have a sum of two products, right? So I have a fraction where the numerator is the sum of two things. I could write that as the sum of two fractions, and I know from my limits that the limit of a sum is the sum of the limits of its constituents, I guess you could say, right? So when I express it that way, I could say that this is really the limit that I'm evaluating, or really the sum of two limits that I'm evaluating. And when and if I do, that will tell me how to find a derivative of a product of two functions. One thing that we might recognize right away is that what I have here, if I take the limit of that fraction, that's really the definition of the derivative, specifically the derivative of f of x. So the limit of the fraction in yellow is really f prime of x. And x is a constant in the limit because it's delta x that's approaching 0. X is not approaching anything. So this second limit is really g of x times f prime. Now, if I look at the first limit, and I'm going to circle a piece of that fraction, well, it's really, again, the definition of the derivative, but this time applied to g of x. So the limit of that green fraction is essentially g prime of x. And then finally, if I look at this first part, well, that's a pretty easy limit to evaluate. As delta x goes to 0, f of x plus delta x becomes f of x. So that means that my first limit is basically f of x times g prime, and my second limit is g of x times f prime. I have an extra line of algebra that I did there, and but there we go. So that's the derivative of a product of two functions, f of x times g of x, and again, it has the beautiful name of product rule. Right? So we're going to now do a couple of examples where we apply this product rule. And the first example is going to be this one. Now, I deliberately chose a function for which the product rule is kind of stupid, because if I want to find f prime, I really could first start by distributing the x squared to everything I got in parens, and then taking the derivative term by term. But I'm going to use the product rule first. I'm actually going to do it both ways. I'm going to use the product rule first, and then I'm going to do what I mentioned earlier, which is distribute the x squared and do it that way. But anyway, I'm saying lots of words. So to make my life simple, I'm going to say, I don't write in blue. I'm going to say that y is equal to x squared times the quantity x squared minus 2x plus 5. And I'm going to label some stuff. I'm going to call this first piece f of x. And I will call this second piece, what's in my paren, g of x. And I can say then that y prime, which is really the derivative of my original function, right? Y prime is going to be the, well, as I said, yeah, the derivative of the original function. It's going to be f of x times g prime of x plus g of x times f prime of x for the f and g that I circled in green and yellow, respectively. So I'm going to plug all of those things in. Let's see, my f of x, the thing in green, well, that's x squared. G of x is x squared minus 2x plus 5, so the derivative will be 2x minus 2, right? And that takes care of the first product, f times g prime, and then I'm going to add to that the second product, which is g of x, the thing that I've circled in yellow, times the derivative of f of x, which I have circled in green. And I'm going to put that g of x in back. So there's my g of x, x squared minus 2x plus 5. And then f of x is x squared. F prime of x will be 2x. So at this point, I've taken the derivative of this original function here. But now I'm going to simplify it, right? So at this point, I'm going to just say f prime. And to simplify what I have here, well, of course, I would distribute and then combine like terms. So when I distribute here, let's see, I have x squared times 2x minus 2. That will give me 2x cubed minus 2x squared. And then when I distribute the thing in the back, 2x times what I have in paren there, I would have 2x cubed again. Let's see, 2x times minus 2x is minus 4x squared. And then I have 2x times 5, which is 10x. And then combining like terms, let's see, so I've got 2x squared, and then 2x cubed, and then another 2x cubed. So it looks like I have 4x cubed. And then I have, let's see, minus 2x squared minus another 4x squared. That will give me minus 6x squared. And then finally, I have 10x in the back. So there we go. So I found the derivative using the product, which again, not the best use of the product. But what I'm going to do is I'm going to find the derivative now without the product rule, just so you'll see again that the product rule is not just something that I made up. It's really a thing. So starting with my original function, I'm going to distribute x squared to the three terms that I have in parens. When I do that, I have x to the fourth, and then x squared times minus 2x is minus 2x cubed. And then finally I have x squared times 5 which will give me 5x squared. And then I could find the derivative by taking the derivative term by term. The derivative of x to the fourth, because of the power rule, would be 4x cubed. The derivative of minus 2x cubed is really a combination of constant times a function as well as the power rule. I think I said product rule the first time. But yeah, power rule, right? So the derivative of minus 2x cubed, well, 2 times 3 is 6, so that would be minus 6. And then x, and then the exponent gets decremented, so that becomes a 2. And then finally, for similar reasons, the derivative of 5x squared, well, I take the exponent 2, multiply that by 5. 2 times 5 is 10. And then the exponent gets decremented by 1 to give me 10x. And we see, sure enough, the derivative matches what the product rule told me. So you might think at this point, hey, I'm kind of dumb, because it was a lot simpler to do it that way. But I just wanted to show you that it actually does seem to work. But now I'll show you another example where you really wouldn't be able to do it any other way. So there we go. So this time I have a function that's a product of x squared times sine of x, and I still want to find its derivative. I'm going to do it again using the product rule. And again, to make my life easier in terms of nomenclature, I'm going to say that y is equal to x squared sine of x. And then I'm going to define x squared as my f of x and sine of x as my g of x. And once again, I'm going to use the product rule. I'm going to say that y prime is f times g prime plus g times f prime. And I'm going to fill in those blanks. In this case, I have no other choice. I've got to use the product. But again, it's not going to be too bad. I'll just fill in those 4 different things. That thing, that thing, that thing, that thing. Okay, so, all right, f of x is x squared. So I'm going to write that. And then g of x is sine of x. G prime would be the derivative of sine of x. That's cosine of x. I got another video on my channel that talks about the derivatives of sine and cosine. But for now, you could just take that as a gift. Later on, you can watch my video. And then let's see. So I'm going to add to that. So g of x, that's sine of x, which I'm going to put in the back here for style's sake, times f prime of x. F of x is x squared. F prime would be 2x. So there you go. So y prime is that. But y is really my original function. So I'm going to say that f prime of x is x squared cosine of x plus 2x sine of x. And there you go. So those are a couple of examples of how this thing called the product rule works. Again, a nice thing when there's no other way of finding the derivative of a product of 2 functions. There you go. I'll see you around.